It says this, Matt. A force of 8 newtons acts on an object for 10 seconds. The mass of the object is 4 kilograms. Matt, what's part A want me to find? Okay, the word magnitude means size. Here's what you just said. Part A wants me to find the answer. What answer? Keep reading. The magnitude of what? What does it want me to find? Okay, one more time. What does it want me to find? You're right. How do I write that? What's our abbrev for change in? Delta. What's our abbrev for momentum? P. So if you ask me to find the change in momentum, I'll write that down first without even thinking about it because, yay, I've written something down, I feel better. This is the impulse equation. Matt, look on your green sheet at the impulse equation. There's various versions of it. Which one am I going to use? Look at the question, see what they gave you, and see if you can figure out which version I'm going to use. You can do this. I got the delta P part. Keep going. Stop. So if it's M delta V, what's the delta and abbrev for? Change in. What's change in anything? What's change in anything? What's change in anything? Okay, final minus. If I'm going to use that, you're telling me this question gave me a final velocity and an initial velocity. Get it? Keep reading. What's another version of the impulse equation? On your green sheet. There's another version of the impulse equation. No. Go look at the impulse equation. There's 3 things there, right? Stop. Did they give me a force? No. We don't use it all at once. There's 3 equations in one. So let's try that again. I think you're overcomplicating it. Which version of the impulse equation am I going to use? What did they give me? A force and a time? Yes? Good. I'm lazy. I generally don't write the delta in front of the t because time is always changing. What is the force? What is the time? I'll bet you can even do that in your head without a calculator. 8 times 10? Units. Okay? It is an impulse. It is a change in momentum. You could say kilogram, meters per second, and I'd be fine with that. But how did we calculate it? What did we multiply together? Force. What are the units for force? What are the units for time? Here, I would probably choose to write Newton times seconds. If you wrote kilogram meters per second, I'll give you full credit. But I don't know if you remember, when I first introduced momentum to you, I said a kilogram meters per second was the same as a Newton second. Usually, if I've used a force and a time, Colton, I'll probably write the units as Newton seconds. If I've used a mass and a velocity, I'll probably write the units as kilogram meters per second, because that's just what's in my brain. Is that all right? Okay, so you're overcomplicating it a little bit. Relax. It's all the information we need is there in that. All right. Good yawn, Aaron. Aaron, what's B want me to find? Good. What's the answer? Too slow. What? 80. Aaron, thank you. You knew it right away. What? You're right. More specific. What did you just say? 80. Why? Because impulse and change in momentum are the same thing. Eric, you're every other class that I've done this for, I've had to do the too slow, ask somebody else. Too slow, ask somebody else. Too slow. You beat me to it. Aaron, you just impressed me. You made my day. So, if I ask for impulse or if I know the impulse, I'm really saying, do you know they're the same thing? Right? Ooh. Aaron, let's keep going. What does C want me to find? What did I find in part B and part A? There isn't by chance a version of impulse that has a change in velocity in it, is there? Doesn't say mass times velocity. Not in the impulse equation. I got to be fussy. Look up. It does not say that in the impulse equation. I'm sure there's another symbol in there, and that's key to this. That's not impulse. That's the impulse equation. The next one over, right?
Yeah.
Impulse. Okay. Look there. Is there one there that has a change? Colton. So, I can also go like this. Impulse is mass times delta V. Delta V, Mr. Dewick. You forgot the delta. Good. Colton, what does this want me to find? It's what? What's my brief for change in? Delta. You know what? It wants me to get the delta V by itself. What's the M doing to the delta V? So, yep. The change in velocity is going to be impulse divided by mass. Now, it's just asking for the magnitude. Most of these are vectors. I was too lazy to give you a direction like north, south, east, or west. That's, Matt, why it said in part A, magnitude. I was just saying I haven't done the directional part. You know what, Colton? You might even be able to do this in your head because it's going to be 80 divided by 4. Yep, loud and proud. Units. It's a change in what? Meters per second. Now, what does that mean? It does not mean that we started at 0 and ended at 20. That's my change in velocity. Here's what it means. If I started at 5 meters per second, what was my final velocity? 25. If I started at 30 meters per second, what was my final velocity? 50. Ooh. If my final velocity was 12 meters per second north, what was my initial velocity? Ella, what's this question asking me to find? What did I find in part C? Noor, what's change in anything? Did you say initial? Did you see the little chain of reasoning? I think now what I would write down is this. Delta V equals final minus initial. I know delta V is 20. I know V final. I need to get VI by itself. How would I get VI by itself? What's right in front of the VI that I don't like? What's right in front of the VI that I don't like? The negative. You know what? I can swappy dance this too. I'm going to plus the VI over to that side. I'm going to minus the delta V over to this side. And I'll get VI equals the VF stays where it was, minus delta V. I don't know if you remember, I said at the beginning of this lesson, I hope you learned nothing new. I hope so far I haven't done anything new except be a little bit clever. What was VF, Ella? What was delta V? What do you get? What's the negative telling me? What direction? What direction was VF? And because you called that 12, you just decided that north was positive. So what direction was my initial velocity? Okay, so if I would accept negative 8, but if this was multiple choice, I might have, instead of negative 8 as an answer to pick from, I might have 8 meters per second south. Just don't say negative south. Okay. So what am I trying to rehash here, Oliver? I'm trying to remind you that impulse and change in momentum are the same thing. And Matt, you've just realized, oh, there's 3 ways to find change in momentum. Well, really the first way is just writing down delta P, but I can find it by going force times time. When do I use that? If they give me a force and a... Or I can use it by going mv final minus mv initial. Colton, when do I use that? If you give me a final velocity and initial velocity. Okay. Losing tension, Oliver? Good. Cole, what's example 2a want me to find? Or impulse, same thing. First thing I'm going to write down, I think, is this, delta P. And now I'm going to figure out which version of the delta P of the impulse equation I'm going to use. Which version am I going to use? Read the question. Ask which one you can use. How do you know? Did they give me a final velocity and an initial velocity? Yeah. Instead of writing m delta V, I'm going to write it because what's changing anything? I'm going to write it as m V final minus m V initial because I think that's a little easier to type in my calculator. Cool, keep going. What's the mass? Okay? And now let's pause for a second. Look at both velocities. Is there any hint that we need to let one of them be positive and one of them be negative? Is there an east-west in this equation? No. Is there a north and a south in this equation? No. Is there a forward and a backward in this equation? Is there an up and a down in this equation? Is there a left and a right in this equation? I think that's that's every opposite direction I can come up with. So I think we'll assume both of these are in the same direction. We'll make them both what? Yeah. What's V final then? What's V initial? Okay, what's the impulse? What's the change in momentum? I think in the 5,000s, but don't quote me much more than that. What'd you get? 5425? No decimals? Worked out evenly? Anybody else? 5425? Yep. Units. Okay, I would take Newton seconds if you felt like it. I would accept that. But how did we find the impulse this time? We multiplied a mass times a velocity. What's the units for mass? What's the units for velocity? I would probably write that just because that's what's in my brain. I've gone to mass times the velocity. I'll go mass times velocity in my units. But if you also wrote force times Newton seconds, I'm good with that. Let's keep going. What's B want me to find? Force. Okay? Put your pencils down, look up. Tony, sit up. Ready? I will give you full marks if you do this. Don't write this down. F equals what? Do I know M? Do I know A? No. Could I find it? Yeah, I could go. Don't write this down. What's VF? Cole? What's VI? What's that 60? And then you could go VF equals VI plus AT. Get the A by itself. A equals VF minus VI over... and you will get the right answer. But what I'm trying to show you is the impulse equation is a very lovely shortcut. Because what are they asking me to find? What did I find in part A? Is there a version of delta P that has an F in it? Look at your sheet. Get the F by itself. How would you move the T over? Write this down, folks. Matt, do you see how I lifted that from that equation? I said I can get the F by itself. And now, instead of about 4 lines, 1 line, and we're home. Because what's delta P? Good. And what's T? So this is why yesterday, Cole, I said the impulse equation, it's redundant. You can survive without it. It's a nice shortcut if you really wrap your brain around it, though, because that saved us about 4 lines of writing. What'd you get? Is that right? I'll code 90.4. And it's a force units. So here is yet another equation for force. Do I need to memorize it? I think I can derive it when I need it. Okay? Ooh, let's kick it up a notch. Example 3. Let's do a little rocket science. I like rockets. Gerard, you ready? Okay. A rocket of mass blah blah starting from rest. I would probably underline the phrase from rest is acted upon by a net force of blah 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 for 120 seconds. What's the final velocity of the rocket? Okay. Gerard, what's this asking me to find? Look up. Don't write this down, but look up. I'll give you full marks. I have no problem if you go, What's VI? What's T? What else do I need to find VF? And I can find A by going F equals what? And solving for A, then what? You can go ahead and do that. But I'm going to see if I can do this in one line. Here's my next clever move. I'm going to write, and this is going to sound silly, impulse equals impulse. But look up. Colton, you too. I'm going to write impulse equals impulse. Colton, you with me? You were zoned out there because when I said look up once, you didn't. You're not staring at your phone or anything. That would be foolish, right? That was your calculator. Okay, I figured so. You're actually pretty good about that. Not like Matt. Hey, any of these 0? So that's going to get rid of this whole term. What are we trying to find? Get the VF by itself. Do you see what I'm saying? Why it's a nice shortcut? One line, we're home, as opposed to 5 lines. You don't need this to survive, but the impulse equation. By the way, there's yet another equation for VF. I'm not going to write it down. I'm not going to record it or memorize it. I can derive it when I need it. It's going to be, what was the force? 2.3 times 10 to the 4th. Time 120 divided by 2.6 times 10 to the 4th. All of you should try typing this in. Try typing this into your calculator because it's got scientific notation. See what you get. It's not going to work out evenly, I don't think. I think it's going to be kind of a yucky decimal. 106? And a bunch of change? Is it 106? Yeah? Units, it's a velocity, Gerard. Okay? And again, I hope you didn't learn anything. Because you could have solved this already, but I don't know if you could have solved it in 2 lines. Yay, handy shortcut. But if you're not sure how to solve it in 2 lines, do it the longer way. I'm fine with that. Calculator trouble? Colton or not? You sure? Okay. Example 4. Okay. Gibson, what's example 4 asking me to find? F equals what? You could do that. Do you know A? Could you find it? Yeah. But the fact that I see a final and initial velocity and a time, I'm going to see if I can write impulse equals impulse. I'm going to see if I can again write force times time equals m v final minus m v initial. Are any of these 0? Oh, to a halt? I probably would have underlined that mentally. So VF is 0, so I get that. What's it asking us to find? Could I also give you the force and say find the time? Yeah. Could I also give you the force and the time and say find VI? Yeah. What's it asking us to find? Get the F by itself. How? Gibson, how will I get the F by itself? First of all, let's go basic. What's the T doing to the F? What's the T doing to the F? How will I move it over? Yeah. What's going to drop down like a domino? Right side. The negative included. Negative MVI. So don't panic if it looks ugly. Just follow. I've taught you well. You can handle it. It's going to be negative, what was M? 1600. VI, 32. All over 1.6. I do that in my head because the 16 and the 1.6 are going to cancel. Is it negative 32,000, I think? Yeah. Double check. Yes? Okay. Negative 32,000 units. It's a force. Newtons. What's the negative telling me? If the car is going north, which way does the stopping force have to be? If the car is going right, which way does the stopping force... You know what? Let's go basic. If the car is going forward, which way does the stopping force have to be? Backward. Okay? So I didn't give you specific directions here. If this was a quiz or a test question, I either would have said magnitude only, or I would have said magnitude and direction, and I would have given you some directions. But this question here has no direction, much like your few. Anyways, it has no direction, right? Let's really kick it up a notch. This is a much more difficult question. This is probably more difficult than I would throw at you on a test. Wait for a few minutes. We just had lunch. Here we go. Mara, I know you were away, but that's okay. What's this asking me to find? Okay. My first thought would be, well, F equals what? My second thought, don't write this down, would also be, well, maybe the impulse equation, which is F equals delta P over T. Did they tell me the change in momentum in here, folks? No. I think I would abandon this. I think I would go with this. Do I know the mass? Do I know the acceleration? So even though this is saying find the force, you know what I'm going to spend most of my time finding? So I would walk over here, I'd probably draw a little line, and I would go, okay, A equals question mark. Which acceleration is this? It's not 9.8. This is the acceleration of the ground bringing this rock to a stop. To a what? What's VF? What's that 0.35? Can I use that D equals 40? Is that the stopping distance? No, that's the falling distance. Okay. What do I need to find A? What's VI? I'm going to add two letters. I think VI is the impact velocity, how hard it hit the ground at. Do I know that? Let's draw another line. Okay. Now what? This is a much, much tougher question. Well, what haven't I used yet? I have. What haven't I written down or used at all yet? The 40. You know what? Oh, I think now, if I just visualize, we're dropping the rock. That's the impact velocity, but in terms of free fall, what do we call that velocity there? I think that's V final at the end of free fall is V impact is going to give me A, is going to walk me over here. Whew. Okay, so I'm going to write down VF equals, and this is where we're running into the, do I have enough letters in the English alphabet? No, because this V, these are all different V's, and we're going to have to keep it straight. If you want to, you can make a little note off to the right here. This is when we're in free fall. And you can make a little note up here. This is when we're impacting the ground to help you keep them straight. Hopefully, if nothing else, this year, you've learned that you can be lazy but organized. And if that's one skill that I give you for your university days, that you learn how to take good notes without writing down every word, subscripts are very handy, abbreves are very handy. Okay, Mara, let's find then V final. Oh, do I know V initial? I think dropped. Oh, I know A. Not to be confused with the A that I'm trying to find for F equals what? Yeah? Ooh, what's D? Negative. Why negative 40? Okay. I'm looking for an equation that's got a VF, a VI, an A, and a D in it. There is one. Why'd you waste my time? VF equals 2 times A times D square root. I think is what you probably meant to say. Oh, at least you didn't say cubed. So it's going to be the square root of 2 times negative 9.8 times negative 40. I think this works out evenly. No, it can't be 28. It can't possibly be 28.
Oh, negative.
Negative 28 I would accept. I'm pretty sure we're on the way down. That's why I answered so quickly. As soon as whatever you had said, if you didn't say negative, I knew that had to be wrong. Again, this is where our calculator assumes we want the positive root. We know better this time. Okay. And that's going to go wafting over to there. How can I find A? Over T. And now VF on impact is 0 at the end of impact, minus negative 28 VI, all divided by 0.35. I think this will work out nicely. 80. And now I can walk this over to there. Whew! F equals 2.5 times 80. 200 even? You could also have gotten there using the impulse. You could also have gotten there writing this same equation down, not having to cross out, but it's doable as well. I'm not going to give you one with this many steps on your test, but we can handle it. It's just a little confusing because your initials become your finals, become your initials, become your finals, become your what? Pardon me? We'll see. I will say this, my angels. I like example 6, I like example 6, I like example 6. Example 6 is a nice question. Tony, what does example 6 want me to find? Next time go during lunch. Sorry? Again, look up. I would have no problem, don't write this down, if you went VF equals question mark. If you went VI equal, hey, I know VI. Oh, I know time. What else would I need to find VF, Tony? A. Do I know A? No, I could figure it out, but you know what? The fact that they gave me a force and a time and one velocity, I'm going to see if I can use the impulse equals impulse trick. I'm going to write this. Force times time equals m v final minus m v initial. Impulse equals impulse. I also notice one more thing that makes this question challenging. What word is this right here, Tony? What word is this right here? We're going to have to let one way be and one way be. Tony, what do you want to be positive? East or west? I don't care. Pick. East. So, folks, I'm going to do this. I'm going to put a positive there, a positive there. Ooh, this 350 is negative, and I'll put a negative in front of the west. Do I need to put a negative in front of the 0.075? Times the scalar, doesn't matter. Okay? And now you're getting a bit of better idea of the difference between scalars and vectors and when we have to worry and when we don't. Tony, what did you ask me to find? Get the VF by itself. What's going to drop down like a domino? Yep, you're right. Someone whispered it quietly. I think was it Josh? What? What's going to drop down like a domino? Yeah, let's do that. Let's not panic. Okay. How will I move this M over? How will I move this over? Which one am I going to do first? Reverse bed mass. So Tony, talk me through it. FT. We're getting the VF by itself. What am I going to write now? FT. Yep. Keep going. Does not get in the VF by itself. Yeah. There is yet another equation for VF. Aaron, am I going to memorize that? Am I going to add it to my sheet? Your sheet would become an encyclopedia of just gibberish. Like, you can't keep all these straight. This is why, from day one, I've been teaching you formula manipulation. But now we've got it. What's F? Why negative? Because that's what you decided. What's T? Plus, what's M? What's VI? Positive 4.65, all divided by 4.2. All of you should try typing that into your calculator. We've done stuff this tough before on our calculator. You can handle it. Are you going to get a positive? I think you're going to get a negative answer. Negative 1.6? Even? Oh, it's a fluke. I normally don't care about you guys enough to make it work out even. Units, it's a velocity. What's the negative telling me? Because it does say magnitude and direction. So I'm going to now write 1.6 meters per second at direction. Oh, how do you know? Okay. Now, let's suppose Cole had decided that my morning block, they decided to let east be negative and west be positive. Then we got a positive 1.6, which worked out because we had let west be positive. As long as you're consistent with your direction frame, you'll be okay. Just don't change partway through to match your neighbor or something like that. Okay. Noor, what's example 7a asking me to find? What's another word for impulse? Let's write down delta P equals. Which version of the delta P equation am I going to use? And why? Yep. How do you know? Two velocities, a final and an initial. Yeah. They did also, oh no, they didn't give me a time or a force. Okay, so I'm going to go, instead of writing m delta v, I'm going to write m v final minus m v initial. Are there any changes in direction? Do I need to let one of the velocities be positive? Whoa, wait a minute. What's v initial as a number exactly? Okay. It's going, ooh. What don't I like about this question? Do you see it? Blech. Cross out 12 grams. How do I convert grams to kilograms? Kilo means 1,000. You have to divide by 1,000. You might even be able to do it in your head if you divide 12 by 1,000. Can you?
0.01.
Yep. Kilograms. So it's going to be 0.012 kilograms, and V final is 250. Which is what? 3 even? Units. Yeah, change in momentum. Or I would also take Newton seconds, but I would say you really did go mass times velocity, but they're interchangeable. Okay. Keep going. What does B want me to find? On what? Don't write this down. Well, write down part B, and then I'm thinking either this or this. Right? I can get the F by itself in the impulse equation, divide by T. Here I would need T, then I could drop this down. Here, what do I need? And so honestly now, we're kind of halfway through both. What's going to be easier to find, A or T? I would probably go with this, just because none of the A's are quadratics. Sometimes the T with that squared was a full quadratic. So here I would probably go with this. But it really is now 6 of one, half a dozen of the other. We're pretty even. Okay, so A equals question mark. What else do I know, kiddo? What? What else? What? What else? What? Do I need to make that negative? No, this is forwards, not below. Okay, which equation? VF squared equals VI squared plus 2AD. Why'd you waste my time? Get the A by itself. So the VF squared would drop down like a domino, right? You would minus the VI squared over, but is VI 0? Yeah. So now get the A by itself.
VF squared divided by 2.
Yep. It's going to be 250 squared divided by 2 times 0.85. Should a bullet have a pretty big acceleration or a pretty small acceleration? Which one of those? It's a bullet.
Big.
It's going from 0 to really fast in a short distance. Let's try this again. I'm sorry. I didn't ask you the question correctly. Will the bullet have a really small acceleration or a really big acceleration?
Really big.
Oh, good. Thanks for picking up on the little hint there. So if I get a big answer, I'm not going to panic. What do you get?
6,000.
Is that right?
That's right. 36,765.
3, you know what? I'm going to go like this. Because this isn't what they wanted me to find. I'm going to write 36800, but really I'm just going to go, I'm putting my answer button right there, right? F equals, what was M? This is your cue. What was M?
0.01.
Good. A, answer button, right? What's the force on the bullet? Even? No, 441 and change? Newtons. If you had to, if that was on a test, could you have figured all of that out on your own? Again, I'm going to argue part B, really nothing new there. The big decision was, do I use impulse or do I use F equals MA? Either would have worked. Oh, if you were finding time, you would have had T, VF, VI, and D. You would have had to use the time equation with the brackets in it. The D equals bracket VI plus VF close that one and get the T by itself. Doable. but